Okay, so let's continue with this OS dev here. One thing I've been neglecting that I've been talking about that I haven't done yet is handling backspaces right. So I don't have backspace handling in my thing. Now, the BIOS interrupt 10, the AH0E, if you type stuff and you press a backspace, it does accept that it processes backspace correctly. It moves the cursor back one, right? But that's all it does. It doesn't clear the screen there. It doesn't do anything else. It does move the cursor back and then you can overwrite. So, but that doesn't really do anything there. Alright, so I want to handle backspace because I've been annoyed at that for a while and I don't think it'll be that hard to do. But let's just see. If we go into our source, let's go to the kernel. Where are we getting the keys? Right here in the key loop. So we're just only checking for enter. We're running the user input. Printing to screen. So this does handle backspace with this print, the BIOS interrupt 10. It just moves the cursor back one space. But I don't want to store the input if we do a backspace, because then that will store the literal backspace character, whatever it is for the ASCII character set. I don't want to store it. Instead, I think we can just decrement. We can either decrement SI to coincide with the cursor moving back, because int moves the cursor forward, or we can just keep it the same and not do the interrupt at all. I'm not sure. If we run the interrupt, the cursor does move backwards, so I think we can just do it after here for one case. ASCII table, what is a backspace? Okay, so a backspace is hexadecimal 8, or octal 10, BS backspace. So let's try hex 8. So search for 8 and hex. I'll put 08 so it looks a little bit better. I might just go through and change all of these into their, subsequent, their versions with the H instead of the 0x. Probably we'll do that off stream and then just give an update after I've done that, but that is extreme yak shaving that we don't need to deal with, bike shedding, whatever. So we'll compare to 8. So I'll do backspace, question mark. Okay, if it was a backspace, then we don't want to put this into SI. We don't want to put the backspace character into the string. We want to, I guess, move the string back. It's already been printed at this point, so the cursor is moved back to one column on the screen. So I think we just decrement SI. I think that's what we'll do, but if it's not backspace, we'll move to not backspace. If it is backspace, then we'll decrement SI, and I think that'll be okay. I'll do a dot here, not backspace. We don't want to increment the byte counter. Probably want to decrease the byte counter as well. We'll decrement CX also. We'll do this and jump back to key loop. Okay. So let's see what that does. I don't know if that'll do much. Just decrement and go back. It's probably the wrong way of doing things, so it won't work at all. Stuff never works the first time, especially when I haven't done it before. Let's see, dir, I mean that works. dit, oh, I didn't want to press that. R. Oh, hey, look, it works. Let's try it with something longer, right? So print reg is that, dir. So let's go print regal. Well, that doesn't work. Oh, I don't want those two things anymore. So that should decrease it by 2 and move back. And that still prints. So maybe we want to output... I'd have to query and get either where the cursor is or this determine this position within the video memory, the byte location of the character. But if I wanted to get rid of the characters after backspacing, then I'd have to do something a little bit more. But right now, since it just prints, it's okay. But I can even see I backspace the whole line. That should be okay. Even though if I do it at the beginning of the line, I think the byte counter would be negative, so it's not going to work. Like if I don't do anything, backspace twice and then do dir. Yeah, it's not going to work because it the byte counter will go to, I don't know if it's signed or not, but it'll go to 0, -1, which is 65535. It's the max value, pretty much, I think, if we're doing 1's complement or 2's complement, whatever it is. But anyway, basic shutdown, you do 2, it's not going to work. Well, it does work, but if I did this, it's like, oh, I don't know what that is. Oh, missed that, go back to, hey, it works. If I do a bunch of spaces, nope. That doesn't work. but I go back and it works. So I think that's a pretty good easy way of handling backspace. We don't get rid of the characters at the cursor, but that's okay. I can handle that later. I want to change the clear screen. I want to write to video memory in the clear screen thing that we're not even using because we couldn't get scrolling to work. So I'm gonna do writing to video memory. Actually, I'm going to maybe call this something else. This is clear screen. I'm probably will have different things according to if we're in text mode or graphics mode. So we're gonna move clear screen will be clear screen text mode. I also found in my other personal projects moving to, I guess this is snake case or whatever they call it, with all the underscores. I find it helps me as far as readability at a glance. Usually I do the camel case things like there, the reset graphic screen, reset text screen, but I don't, for some reason with the snake case and the words written out, it just, I don't know. It helps me at a glance. I can see it and understand it just like a split second faster. And I think it's a little more readable and a little easier to read, so, which is the same thing, that's redundant. But anyway, I might try to name things like this going from now on. We'll see. Let's go into clear screen text mode because I'm talking too much. So we call clear screen, which we're assuming 80 by 25. I guess I'll put that here. We're assuming VGA text mode 3, which is 80 by 25 characters and 16 colors for this one until we change it later. Let's just get rid of all this stuff. So what we can do is move CX, since I'm going to have a loop that writes to, I guess, every byte on the screen in video memory to clear it, is what I want to do here. So I want to move the number of bytes we need to repeat something if we want to do like a repeat prefix for our string operation. Since we're doing VGA mode, we can move just a null byte or a space and then the color for that in the next byte, because each character in video memory, you have the character and then the attributes for the character, the colors, and like a blink bit set for the cursor or not. But if you have the character and then the color in the next byte, and the character takes up 1 byte for, you know, regular ASCII, then it's 2 bytes, so that'd be 1 word value. So how many words do we have in the screen? We have 1 for every character. Since it's 80 by 25, we can do 80 times 25, which I think is 2000, but it makes a little more sense if I just write 80 by 25. And what I can do is move, since I can't move things into the extra segment, and I like to write this using the extra segment with DI as an offset, you can't move immediate into the extra segment, so I'm going to move it into AX first. I guess I should do push A because I'm affecting registers here, so that's fine. Video memory would be B800, so 0B800, H, move into ESAX, okay, XOR DI. That's video memory. SI, we can set to null or something. Or we can even do AX, XOR AX. We'll try it with null bytes and see what happens. I don't know if it'll overwrite the background color or not. I feel like the palette, making the palette blue or making the background blue with the reset text screen keeps the background, but I don't remember if that was correct or not. I feel like that's right, but I'm probably wrong. So we'll see if this resets the background to black, since the VGA color 0 is black. We'll see if it does that or not. Okay, and the number of characters to write. So then we should just be able to repeat store string word, right? And that should store AX, 2 bytes and AX to DI. And then it should increment DI. It shouldn't increment AX, right? Let me make sure. I always forget these things. It doesn't say. See, I'm hoping that it keeps putting AX in and does not increment AX. I don't think it would. Of course. We'll see what this does. That would clear everything. This would not move the cursor, however, so I do want to move the cursor after I do this. So afterwards, move, I guess it'd be hardware cursor, mouse cursor, whatever you call it. Afterwards, after we clear the screen with this, I'm just going to move it to the top left of the screen, to 0, 0, row column. And to do that, we can use int10ah2, int10h. So move ah02 It's either DX or DH. What is it? DH and DL, row column to set the cursor position. DH and DL, row column. Okay, so if we just XOR DX, then it would send it to 0, 0. Let's do that. That cursor out of the way. XOR DX, DX. Okay, so 0, 0. So it should fill the screen with null bytes. And then black foreground and background. I guess instead of that, what we can do is just get rid of that. Let's move into AH. Let's do let's just do a space. And AL, let's move the attribute. Let's do we're using blue background right now. So I'll do blue background. And then the foreground doesn't really matter because it's a space, but I'll do whatever the other characters are in the editor for right now, that's light gray. Okay, so 1 is blue and 7 is light gray in VGA colors out of the 16 colors. So let's see what that does for clear screen text mode. So where am I going to put that in? In the kernel, in the editor, where? I don't know if I referenced it in the editor, probably not. I didn't save any changes earlier, so that doesn't matter. Call reset text screen. So let's call clear screen text mode, which means I have to include the file down here. This will be clear screen text mode.asm, and let's see how it works or not. Probably doesn't work. So how does this clear the screen? Well, it doesn't, of course, because why would it? Yeah, that doesn't look good. I don't think that works, which is okay. The page number is probably going to be 0. Let's just XOR it anyway. So BAH equals page number. No, we get a whole bunch of garbage. Nice. Well, that's always good. Just to see if this is the issue. Move AX into DI. All right, and increment DI twice. Well, increment once. And then loop dot loop. It's the X number of times. No, it just gives garbage. Well, that's always good. Actually, you know what? I wasn't doing 17 in hex. Let's try it with 17 hex instead of 17 and see what happens. No, that doesn't work either. Okay, well, let's try the other then. Let's try it with this one being 17 and this one being space. They both do the same thing, which is garbage. Do I have to specify word here? Probably not. Let's just try it with AX XORed. Did anything different happen? No, nothing different happened. It's like it's not loading it, but why would it not be loading it right? So it's reset text screen, right? Isn't that what it is? Let's just call reset text screen. I don't know why it wouldn't even be able to call it though. I didn't really change anything. 1, 2, 3, 4. No, so I messed everything up. Let's check calculator. Calculator doesn't work, then I've definitely messed something up. Yeah, so I messed up. It says program loaded. So it's not seeing it as bin, or it's otherwise not looking at them right. So why would it be doing that? If I take the dot out, is the dot messing it up for some reason? I don't know why it would be. But you can never tell with these things. No. I guess take this stuff out of the equation. I should be back to normal, right? I moved A out, yeah. Okay, well that works. I don't know why this is an issue. If we enter a character here, they did not enter this. I guess we'll compare before the int. It's probably the int messing things up. If it was not a backspace, then do what we've already been doing. I don't know, maybe putting it before the interrupt will fix it. I'm not sure why it messes up. I don't know, we'll see if that changes it or not. Does calculator work now? Compare and jump not equal, otherwise we'll do it anyway. See how this does. No changes. Okay, that does work. Otherwise, let's jump key loop. I'm gonna take this one step at a time. Oh, it's the jump. So why would the jump be doing that? So this jump right here, why is this jump messing everything up? I didn't even enter a backspace either. If I don't enter a backspace, this messes up. If I include this jump, does something to do with this? Have we gone to 5 sectors now? I don't think we have. Well, I can try setting this higher. What's 2560, right? Plus 500 and then plus 1260. I don't know why this would matter, but I can try it. So I have to change the file table, because the kernel is now 3 sectors. Or well, no, it starts at sector 2. It's now 5 sectors, sorry. 5. 2, 3, 4, 5, 6, which means this is 7, this is 8, and this is 9. Alright, that also means I have to change the boot sector. Number of sectors to read for the kernel. Oh, maybe that's why this was at 3. That's not good. This was supposed to be at 4. This is at 3. That's probably our issue here. I never changed that to 4. 4 sectors to read. Change this little sucker back. 4, 6, 7, 8. That seems like a bit of an issue. If I'm supposed to be reading 4 sectors and I was only reading 3, it's probably not great. 2048, great mobile game for passing the time. I played 2048 a lot in one of my management classes in college because it was kind of a joke, but we're loading actually 4. That works. That works. Yeah, I'm a big old dummy, and it doesn't give you errors, of course. You're supposed to figure it out on your own when crap doesn't work, but if it's 4 sectors, you need to load 4 actual sectors, not 3, of course. Let's see if this works now. I do want this to be a dot. Don't ask why, I just do. I want it to be a dot because I can set up for later. So, does this work? DIE, nope, DIE R. There we go. Oh hey, would you look at that? Whoa, backspace works now. Wow, I just had to load the right number of stupid things. Okay. Well, we can get back to our original issue at hand then, which is messing with the editor, the clear screen. Let's do that. Source assembly editor. Let's change this back. That's why you save your things here by just commenting them out. So we get quick turnaround time like that. So let's see what happens. Okay, it does not print the cursor or anything on the screen. That's a bit weird. Okay, it does clear it though, and then write the text. So that part is right, but I don't get the cursor. So why is that? I guess moving the cursor does not work. Page number should just be 0. I mean, I can change this though. Move BH 0, or just XOR BH. BH. No, see, I don't see the cursor up there. Row 0, column 0. So what happens if I try to move the cursor somewhere else? I can try like 1, 1, 2, 2, you know. Move DH 2. Move DL 2. I know I could move DX, but I just want to see what this does. Yeah, so why the mouse cursor doesn't show up anywhere? I can change this back. Let me change this anyway to repeat, because that's what I wanted to do. We don't need this garbage. Alright. I don't think that's gonna make any difference, but if it does the same thing, that's good, and it did. The high bit 7, so I have to OR the attribute byte 7 with blink. I can do that. I don't think that's the issue with the blink bit, but I can try it and see what happens. Could also be because AH and AL are both 0. So what I can do is move, again, move AH as this, and AL is 1, 7. Does that change anything? That's definitely not what you should do. Interesting display. Let's move these around. That time I think it did that because of Little Indianness. I don't see the stupid mouse cursor, dude. I didn't disable it, I don't think. This is the attribute byte, so what I could do is try to set blinking on with this. I'm moving the hardware. Maybe it's because I'm moving the hardware cursor and this doesn't work. It's probably what it is. Let's just get rid of this stuff. Let's just get rid of all that. Let's not move the cursor. Don't worry about it. Let's see what happens. The cursor just doesn't show up at all. So what if we don't do any of this, but we do move the cursor, huh? Let's do the opposite. I can do this actually, I just don't have to do this. So, alright, so the cursor move does work. However, filling the whole screen with a color does not. But moving the cursor works. What if we move the cursor and then fill the screen? If we do it after? I don't know why we would. Let's see, let's grab all of this and put it down here. The cursor disappears. So it is with writing to screen. Okay. I can try setting bit 7 on with AH for the blink bit, but I'm not sure if that'll matter, but I can try it. I can OR AH with 1, 1, 2, 3, 1, 2, 3, 4. It's binary. Let's see what this does. Let's see what that does. I don't know if it'll do anything. Well, it shows it, but it's in different color, but it does show the cursor. But I went to light blue and not dark blue. Let's not do underline. Let's set the attribute bit 3, the foreground intensity. Let's set that off. See what happens. Alright, 0, 1, 2, 3. Turn on blink bit and intensity bit. It still makes it, oh, that gets rid of the mouse cursor. Okay. The cursor, I mean text. You can't see text print if I do that. So that's 17 in binary. Blink bit is not. That's disabled. That's not. This probably has to be hex. Was that 17 in H before? I don't think it was. Let's see what that does. Oh, there we go. I'm such an idiot. God. Blue background. Light gray foreground. Man, I'm an idiot. Okay, but this works for the clear screen. And it moves the hardware cursor to the top. So that's good. Actually, now that that works, let's put that in the kernel as well. Here we go. Let's change this. We're going to call our clear screen text mode. Alright, because this works. It works by writing to video memory. It works pretty well. Then we'll jump to get input. So get input does print the prompt. Okay, so we're good there. So where our file includes here. So here we go. Clear screen will be clear screen text mode. Okay. Where do I have reset text screen? Am I still using that? Yeah. Okay, so let's change this back to the other one too. Because this is what I want to move towards. If I can stop using BIOS interrupts for everything and slowly move towards writing directly to video memory or using in-out commands and going to the hardware ports themselves, then that sets me up better to use protected mode or even long mode where you don't have easy access to BIOS interrupts. So, I mean, you can go into virtual 8086, I think, and other ways, but If I can go whole hog into doing this the more legit way, maybe, or the harder way, then it'll be easier to go to protected mode and everything will work pretty much the same. So that's what I'm doing this for. I don't know if I'm going to keep this 16-bit forever, so we can do a lot of stuff with 32-bit that might be interesting and more relevant to people nowadays, I guess. I don't know. Or I can fork the OS and keep one in 16-bit, one in 32. I don't know. But anyway, we'll do clear screen. We don't need to use that anymore. Cool. Clear screen text mode. But clear screen, and then it moves that. Clear screen. Cool. That's interesting. So I have not handled text wrapping. So since we're not fully setting the video mode with a BIOS interrupt, we're only filling one screen's worth of data. So when it scrolls to the bottom, that screen, it goes past that screen's worth of data, so we don't have a background color set. We still have the default BIOS, the default text color for VGA, which is the gray, but we don't have the background set because we only drew one screen's worth of data. So that's funny. That's kind of interesting. So I will look at that. That'll have to be another command or another thing for print character, print screen, and checking if we scroll down or not, I guess. Or we can set our screen once in the boot sector and we won't have to worry about that. So maybe I can do that. Let's look at the boot sector again. So before we jump, we could set our text mode screen. Let's do it here. All right, set up video mode before going to kernel. I'll just put initial video mode before going to kernel. So let's move into AX 0003 and then call int10 VH0B, move BX 0001 int10H. Okay. Okay, so this should do the same thing, hopefully. Then it'll jump. So let's see what that does. So if we scroll off the screen, it is now blue because we set it in the boot sector. Okay. So we're good. So we did do a couple small things. We have backspace working now. Although it doesn't get rid of the text, it does if you override it, and it doesn't overwrite the prompt. Then it does do what you wanted. Oh, I didn't want to do that. I wanted to do PRTREG. Ah, yes. Okay. Calc. Oh, can't do that. No. But calculator. Nope. TOR. And it disregards everything after the last thing in the cursor anyway. So, but that seems to work. Got backspace working. We changed our clear screen. We did some things. We did some things here. Moving the hardware cursor with a BIOS interrupt. I will probably change that to use the hardware ports to move the mouse cursor eventually. Right now I'm not, but we are at least writing to video memory for clearing the screen, so that's cool. I'm actually going to delete that now because we aren't using it anymore. If I can remember how to do grep, so we want to search everything for reset text screen starting in current directory. So calculator uses it. Reset text screen. I don't want that in there. Let's change calculator. Okay. You do not need to use... Oh, I'm not even using it anyway. But we'll get rid of it. Because we don't need to. This resets it anyway. And what we can do instead is just call our clear screen text mode. We don't have to do this. For our testing. And print go back. Just, you know what, just get rid of all this screen. And it works, okay. Okay, hey, welcome back. Got some more OS dev here. I'm gonna do a couple more, well, a couple different sort of changes here. I was wanting to kind of restructure things a little bit and then make another small change to the makefile, of course, and then maybe mess with segments before I go. And I want to change the structure of our project a little bit. I have bin source test, that's fine. That's good and all. In the bin file, we have the os.bin, we have another readme. This is like the very old readme that I've never updated, so I'm gonna get rid of that. We don't really need that. So I have the bin and the makefile. So the makefile doesn't really have to do with the bin. I mean, it makes the bin the binary file, but it's not a binary file itself. If we ever get into more advanced building, I'll probably want to make a build file, so I'm gonna, or a build folder. So I'm gonna do that right now in the base directory here. I'm just gonna make a build folder, and I'm gonna move the makefile into there. Or usually major projects are kind of laid out like that. os.bin, that's fine. So the bin, I want the final binary to be built and contained within there. And that's all it's going to do. Now we have a build folder, which has our makefile, which I'll have to change the definitions in there, but that's fine. We have source, we have test, which is just for testing. I don't really use that. But in our source file, we have ASM print screen. ASM was going to be kind of a placeholder, but I never kind of changed the placeholder for that. But what I kind of want to do is just make everything that's in the ASM file, I kind of just want to be in the source file. And then since I'm including stuff that's in the print and screen folders here, I'm going to put those into an include folder. So it'll be more, I guess, more obvious at a glance of the overall structure, how I want to use these things. So I want to move everything in assembly. If I can do this, I don't know if I can do this or not. Move everything here. Okay. So if we list ASM, there's nothing in there. Okay, remove R. So let's make an include directory. And if we can, I want to move stuff into there. Let's just go into here. We'll make additional print and screen things. That's screen. I don't really want screen in here. I do want screen though. The screen one's fine. I also want to make a disk folder, because I'm going to put in loading and saving from disk here soon, in this video or in the next video, whenever I get around to it. So now I have all this stuff in the base directory, so we go back into source. Let's move everything under print into include print. Okay, and we'll do the same for screen. Print is now empty in here, and should be the same thing for screen. Yep. Okay, and then our disk load we haven't really used, but I'm going to move the disk load thing into the disk folder there. So the only thing we have in our source folder now is these assembly sources. We have an include folder, which I'm going to use as include, like header files in C or something. I'm going to include those to the main sources in the source folder. Just makes a little bit more sense for me. That's how I'm going to lay it out. Okay, so changes that would be involved. Let's go back into here. That's the makefile. Okay. Instead of laying this out for everything here, I kind of want everything in the source folder I'm going to want to be turned into a binary, is how I've laid this out. So instead of doing, FASM and then move for everything there, I'm just going to do wildcards to automatically run FASM on everything in the source folder and then make a binary and put it in the bin folder. Let's remove F. It's one folder up and then it's in bin. Let's just remove all the bins in the bin folder for clean. And then to build everything, I can probably just put it in this main recipe here. I don't really need to do these up here, I don't think. So let's get rid of those. Let's run FASM on everything in the source folder. So everything in there, let's run FASM on it. That should make binaries of all of these files, and then I want to move all of those. So let's get a separate one. Let's move everything. That'll be every binary that'll be in the source, and we'll move it to the bin folder. I can keep cat like this, that's fine, but I want this to take place within the bin folder. So I mean, the simplest way to do is just to do this. It's kind of annoying, but that's the simplest way to do it. Probably a better way, but oh well. Right now, we'll just prep in the file path to every single one and hope it works out. It probably won't, but maybe it will. You never know. Put this one folder up. Make an os.bin over there. And we want to dd that. Temp.bin into the os.bin. Then you want to remove All the binaries except that in the bin folder. Okay. So I'm hoping that this kind of obviates the need for all this. We don't need these anymore because we got them all there. Make run will not really work. We have the box source file in the bin folder, so we'll kind of just run box.q in there, I guess. So I'm going to get rid of this for now. I might put something in later, but right now I'll just get rid of this. This kind of builds it. So we'll see what that does. That probably won't work at all, or it'll error because the include files aren't right, but let's see what happens. It does not like it. Okay. I made a little shell script, executable shell script to just run through all the files, all the assembly files in the source folder, just run phasm on them, and this little, the $sign file. So for file, this is a variable name. So $ to expand the variable name in shell for every file that we find. So every file that ends in ASM in the source folder, we're going to run phasm on that, and it'll contain the path by default. And we're going to strip the ASM by doing %% and then a pattern that deletes the pattern from the end of this variable name. So basically deletes the ASM on the end and replaces it with bin. I think it'll do it without doing this. It'll name it a bin automatically, but I'm doing that right now just to be, pedantic, extra sure. All right, and then the makefile. What I'm doing is I'm running that first off so that it runs and makes all the bins. Then I'm going to move those bins into the main bin folder, and then again cat them all together into temporary and do all this. The include files aren't set up, so obviously this isn't right. That's okay. I just wanted to make sure that that did work. So we do have bins. It does make binaries out of them. It didn't make them all because it stopped halfway. So let's remove all the current bins, and we have those there. Okay. Let's change the include files, right? Let's go to include. Let's see here. We'll go into... I haven't done anything with these yet, but I'm just going to move these. I'm going to rename them with a .inc so that I'm extra sure that they are include files. The extension has nothing to do with the content, so shell doesn't care. The assembler phasm won't care. It'll still take them in regardless if you do include mnemonic. I'm just going to name them include so it makes a little bit more sense. So everything.assembly we're going to make .include. That doesn't work. File table to print file table.inc. Print hex to print hex inc. Print registers inc, and print string to print string inc. Okay. Print we name, so that leaves screen. And we'll move the reset graphics screen as well. Now everything's inc. So the only thing left is to change the include files for these. I don't think the boot sector has includes in them. Calculator does. Eventually I will use this for a calculator, I swear. I'm just not right now. But eventually I will. So this is in the source file, so this will have to be include. And it will be screen, and then it will be clear text. Clear screen text mode. .inc. Editor, does this have include files? It does. Include. I don't want to do that twice. INCLUDE. INC. Okay. File table doesn't have any includes. It does not. The kernel does, though. Kernel has a whole bunch. We'll be changing this a little bit maybe in the future. I might consolidate some of these into their own like overarching methods file or something. That doesn't make sense. Like the print functions here, like print string, I might make a print character, stuff like that. I could put those all into one overall print file, or maybe an overall IO file, like CEF standard IO header. I can make like a standard IO include file that has all our IO functions. I don't know. But that would be everything from strings to disk to loading, to moving memory around, everything. I don't know if I want to do all that in one file. I might still break it up. So I'm still thinking about that. Thinking about structure, not sure how to structure these things. Trying to make it a little bit better. I know this does make the paths longer, but I think it's more explicit. These are coming from the include directory, and they are include files. So I think that makes more sense, personally. It is a bit more to type though. Let's try make. That looked like it worked. So that's still in there. If we look at the output in bin, we have os.bin. If we look in source, we only have these. So I think we're good to go. We got the changed makefile here. I would try to put the assemble sources, that shell, and small for loop. I was going to try to put in the makefile, but I didn't want to mess and debug with it more than I had to. I might eventually try to put some form of that in the makefile to not need the separate, for loop shell script. But, this works, so that's fine. It runs and it makes it. Actually, what we could do is could we run make in the other file? If we do make, and then, I don't know if you can run this. Surely you can run this in the other directory, right? -c directory. What if we do -c build? Okay, so we might be able to do that. Make -c build, and that would build in our current one. Let's see if it runs. Just to, appease my worries. Let's just see if it runs and it works. Okay. So directory works. Print reg. Love that we got backspace working. Print reg works. I might change the registers thing too. Either add the stack pointer or maybe flags, because there's some mnemonics to load flags register into AH, and then I can read the bits that are set for the flags. So I might add that in the future. Let's see if graphics test still works. Yes. Although it breaks it after we do graphics test, it breaks. That's interesting. That's interesting that it breaks. But that's okay. Can still do reboot. So I'll have to look at why that breaks, because that's not great. But if we don't mess with it, it won't matter, right? Reboot works. Shutdown works. Type 4 for the editor. We can run whatever. Let's just go back. File table should print it. Okay, so everything still works. All right, we're good. But the other thing I want to do is change the segmenting a bit, how we're handling segments. So let's just go back to source. We will do the boot sector. So I did look more into the segment memory model last week and everything. So this COO is fine. This down here, 1000. When you move 1000 into ES, ES does not point to 1000. ES points to 1000 in hex times 16, which is 10,000. So I've been loading my file table to linear memory address 10,000 and kernel to 20,000 this whole time. I thought this was an offset, really just pointing to the start of memory 1000, but this is actually pointing to 1000 offset 0, which is 1000 multiplied by 16 plus the offset, which is 10,000. But I had a wonderful guy. I don't know if he wants me to shout his name out or not, so I'm not going to do that right now, but I will give him credit for showing me, what was it, was it this page? Yeah, this, very bright. Just change that with dark reader right quick. Removing the mystery from segment offsets. This page is pretty good. It gives a short and concise explanation of segmenting. Very easy conversion here. Take the segment, multiply it by 16, or add a 0 if you're using hex, and then add the offset. That's how you get your linear address. So, and this goes a little bit more in tune with that. This is, what is this? The Starman, PCMinistry.com, ASM debug segments. So pretty good page. I like it. If you do want to use the segment offset and point to a lower quote unquote memory location, like actually point to 1000, what we could do is probably move 100 into ES and then do this 0, and it would be 100 0, which would end up being 1000. Or we could maybe make ES 0 and BX 1000. So that the offset is 1000, but 0 offset 1000 would still be linear address 1000 in hex. But I'm going to also move BX 0. This can be XOR to take up a tiny bit less space. XOR BX with itself. Let's do that. But yeah, let's do this instead. Let's load the file table to actual location 1000. So we'll move 100 in hex to ES, which ES is a segment, so automatically it'll multiply the 100 by 16, thus making it 1000. Okay, this stuff here, I don't need to do this anymore actually either. Let's XOR DX. Alright, and then we'll move just directly into CX. Does the same thing. We'll do 0006H. Just a little bit less space here. I could do the same for these. I guess might as well. 0201. Alright, then Bx down here, this will be 200. This should actually equal 2000, hopefully. Yes, Bx 200 equal 2000. And this again, we can XOR Bx. Not XOR. XOR Bx with itself to zero it out. Copy that. Let's not do that. Put it there instead. So except this is 2. Read sector 2. And we're going to run this again. To YY to copy the line in Vim, and AL is going to be 4. So this kernel takes up 4 sectors. Alright, so AX2000, let's move 200, since now we want to load our kernel at memory address 2000 instead of 20,000. Stack pointer is not a segment, that's okay. Stack segment, let's put in 900 so that the segment is 9,000 and not 90,000. And this stuff should all be fine. Now we can jump 200 0. Or maybe we can get by with jumping 2000. Let's find out. I'm not sure if we can. We might be able to. Let's see if we can get away with it. Okay, and we're still good, it looks like. So what happens now if we print registers? Nothing happens. That's good to know. I need to change the kernel to work with this, obviously. Because enter is not doing anything. Okay. Let's change the kernel then. Probably because we're doing this. This needs to be 200. And not 2000. And that was probably the whole issue right there. But I'm just going to look through the rest and make sure the file table, that's not true. This is now at 100, or well, at actual location 1000. We can still load, this is loading programs to 80,000. Let's load programs to 8,000 instead. Let's do that. And kernel space, segment 200. It's really just making all these. So this we can just do 8,000 then. So it does make it conceptually a little bit simpler here. It makes it a little bit less stuff to write. We don't need to do segment offset everywhere. This is still okay though. We can still jump to this because we're in 16-bit mode. We would need to do 32-bit if we wanted to actually put the 0 on the end. Since we're in 16-bit real mode, this one does have to be segment offset for the reset vector. And this does equal FFFF0. But that one is still okay. Are there any other segments I should know about? I think we're good. I think we're good here. Okay. Let's run QEMU again. And let's see. Okay, print file table is not referencing the right segments. That's true. Print register is okay though. It looks like it's printing. Yeah, DS is 200 and ES is 200. So even though the segment registers contain the value 200, the segment registers are actually pointing to, or well, when they're used, they're pointing to linear memory address 2000. So it is confusing. These ones though are the same. If AX held 200, AX would be pointing to address 200, but the segment points to the number times 16 plus an offset if you have that. But the segment points to the number times 16. It's really annoying. It's dumb. I looked up some, I think a little bit of 68K, Motorola 68K assembly, and it was a lot more sense than x86's garbage. I think it had like 8 address registers and 8 data registers, and you could just use any of them. You just point one to the other, or something like that. But it was a lot more sane, and it made a lot more sense. So that's why I drink wine, right? So we have this almost working. So the file table did not work. What other files have we not messed with? The calculator. So let's do that. We're messing with segments in here? Yes, we are. If we did this, it would not have worked. Let's be 200. All right. Let's change the editor as well. Well, no, B800 is correct here for video memory. Or well, the memory address for video memory is B8000. Since we're already moving B800 into there and it multiplies by 16, it points to B8000. I didn't splice this in here. The memory map. So wiki.osdev.org/memory_map_ parentheses x86 parentheses memory map. Really useful. This is what I've been using. So you have unusable data. Your memory starts with, the interrupt vector table, the BIOS data area. Conventional memory, 500 is 7BFF. So 7C, this is where your bootloader is loaded at, 512 bytes. Then I'm using basically this memory here between 7E00 and 7FFF. Well, I'm using a little bit down here as well. I'm using 1000 for the file table and I'm using 2000 for the kernel. But then above here, I'm going to load programs, hopefully to 8000, which is kind of right above, a little bit above here, 8000. And then the stack is at 9000 to FFFF, which is right below 10,000, which is still like 60,000 in hex away from this limit. So it's pretty good. We have a lot of space to work with here for now. 480 kilobytes isn't a lot, but right now it is. When we eventually move into 32-bit, we can use, other spaces, but yeah. But okay, segments, restore extra segment. This needs to point to 8000, which is where our program's loaded now. Seeing if there's any other segment garbage I have to look at here. Let's do W. Jump back to 2000 where the kernel's at. Include, okay. So that should be all right. Include, and then print file table, right? Yeah. So since I named this INC, I'm not going to get syntax highline, which is nice. I'd have to do this every time, which is annoying, but that can work. Actually, I like the NASM. NASM one's better. I can set that in my vimrc. I'll probably change that after this. File table segment, that's at 100. We might as well look at all these just to make sure. All right, so directory should now work. Okay, print registers should work. Should be able to load programs, which we're not, so editor does not work. Loading programs is not working. That's always good. And so the load program code is not working. Did I call it run program? I did. 200 is kernel space. That should be okay. 800 is where we're going to load the program. So this jump is not working. Maybe the jump isn't working as a far jump and we need to change it. That could be right. So it's possible that I do need to put a far jump here anyway. Possibly by doing this. 0. I can put a 0 in front of the 800 too. I'm not sure it would matter though. Let's try that. Yeah, that's what I had to do. So I do have to do a far jump. Okay. And this isn't going back either. Because I don't have a far jump there in the calculator. This is fun. Hopefully this isn't too annoying to watch. Hopefully it's kind of interesting. At the very least, this shows how annoying segments are to work with and deal with. They're easy when you don't know what's going on, but when I attempt to simplify by not needing offsets in some situations, to do a far jump, I guess I still need the offset. So that's okay. I'll have to change the editor as well. This jump here. All right, so this should load, and we should go back. 1, 2, 3, 4, and we can go back. Okay. But I'm going to do some editor changes definitely. I want to put a message at startup that says, do you want to load or create a new file? And then it'll ask for if you want to make a text or binary file, I guess. And if you choose binary, it'll go into the current hex monitor. If you choose a text file, I want to make it go into like a generic text editor mode to put in whatever ASCII character. But the hex monitor, I'm going to change to like only take in, 0 through 9 and A through F. And make it automatically capital so that you can't mess up. And also put in backspace support. And then also a couple other things. And then put in saving and loading functions to save and load to disk. And then we'll go from there. Yeah. I'll see you in a bit.